New factories have risen with unprecedented speed. Yet these vast production facilities would amount to nothing without men to keep them running at top speed. Said production-wise William L. Knudsen, dedicating a new plant.
The most important factor in the operation of the plant is the men that are going to run the machine. You're the men that are going to get the job done. With your two hands, you're the ones that are going to save and finish the American defense program.
3 shifts a day they stream into the factories to get the job done. From farm and city they come, from store and office. Thousands of men learning new trades and taking their places on the vital production lines. In 3 shifts they come, laboring by day and throughout the night in producing air power, fighting power to give the Army Air Corps mastery of the skies. Before actual production begins, every new type of military airplane is completely manufactured on paper. More hours devoted to advanced planning spell fewer hours consumed in manufacture. The next step, which precedes production in order to speed production, is lofting. Here the aerodynamic lines and shapes of the various parts are laid out full size to develop the templates which guide the forming of the various metal shapes. The templates are meticulously checked back against the original drawings, for upon them will depend the uniformity of parts so essential to quantity production. Simultaneously, the pattern shop constructs the mock-up, a wooden facsimile of the airplane which is used to perfect the multitude of details and create molds and dies for various formed parts. When all templates and molds have been completed, the airplane is released for production. Guided by a template, the operator is here setting a shearing machine to the approximate size of the part which is to be cut from the aluminum sheet stock. With the machine locked in position, the template is removed and a sheet of raw stock is set in place. The initial shearing cuts a small sheet approximately the size needed for the part. This cut sheet is then trimmed to exact dimensions. To guide subsequent forming operations, pilot holes are drilled in the sheet. Again, a template controls the work, governing both location and size of the hole. This sheet, which is to be formed into the leading edge of the elevator, will be followed through all operations, as it typifies in its forming many airplane parts. When all pilot holes have been drilled, the sheet is stacked with others which have been similarly drilled. These are mounted in a wooden form block, which was accurately patterned from the original template. The sheets are now ready for the next operation, routing. Here, a sharp routing tool is used to cut the sheets following the contour of the form block. This machine is capable of profiling from 10 to 20 sheets at once and is a good example of the manner in which, wherever feasible, mass production methods have been applied to aircraft manufacture. After being profiled, the leading edge of the elevator and other parts which must be bent are shaped in giant automatic rolling machines. Here, the part is rolled back and forth under pressure until the desired shape is obtained. The degree of curvature is accurately controlled by an automatic feed system to safeguard against undue strain in bending the metal. One blow from this automatic press fixes the bend in the metal so that it will hold its shape permanently. The piece is next set up in a jig for the hand shaping of the flanges. The forming of all like parts in identical jigs assures absolute uniformity of the parts and perfect fit with other parts in assembly. Use of wooden or rawhide mallets protects the relatively soft aluminum alloy. When the flanges have been bent exactly to match the shape of the jig, the forming of the part is complete, and it is ready to be moved on to subassembly. Meanwhile, thousands of other parts are taking shape in the skilled hands of expert metal formers, employing a variety of methods. Here, a high-speed trip hammer is being used to dish a sheet of metal. The stretching of the metal must be gradual to avoid damage and waste. Portions of the fuselage skin are among the parts shaped by this method. Each formed part is carefully checked against the mock-up for exact fit. Many large circular parts are formed by metal spinning, a mechanized high-speed application of the ancient art of wood turning. Bulkheads, ribs, and other structural members are stamped on mammoth drop hammers. Operators must be well versed in the peculiarities of the various aluminum alloys to know how far the metal may be drawn safely in a single operation. Just as in every department, experience and skill peculiar to aircraft construction must be acquired before a man may take up his job. Hydraulic presses form many of the odd shapes found only in airplane construction. For this operation, a cushion of rubber sheeting is built up on top of the raw material which has been placed on the die. The press forces the rubber to bend the metal into conformance with the die. Accurate placement of the rubber sheets is essential to equalize the pressure over the surface of the metal. In the machine shop, countless other parts are formed on engine lathes, automatic and hand screw machines, external and internal grinders, milling machines, drill presses, and other machines common to industry in general. Since it has not been feasible to employ single-purpose machines very extensively in airplane construction, operators must be capable not only of running the machines, but also of making the special setups necessitated by the wide variety of jobs performed on standard machines. However, in the new race for quantity production, much specialized machinery has been developed. Typical is this automatic milling machine for wing cap spars. Here again, a template guiding the cutter ensures uniformity of parts. Since the clamps drop off as the cutter approaches, the milling is accomplished on top and bottom simultaneously. Most parts of the airplane are subjected to one or more special processes which increase the serviceability of the metal. Here, for example, finished parts are being heat treated. In one tank, the parts are brought to the desired temperature in a hot solution. They are then quickly quenched in cold water in the other tank. Heat treatment strengthens the metal so that it is better able to withstand the stresses and strains to which all parts of an airplane are constantly subjected. In the anodic process, another treatment given various parts, a thin coating of pure aluminum is deposited through electrolysis on the surface of the alloy. This oxidation coating is important for its corrosion-resisting properties. All parts which are to be painted are first passed through two hot cleansing solutions. This removes the preserving coat of oil and all dirt which the parts may have picked up in forming. The parts are then suspended on a traveling conveyor, on which they are given a protective coating of chrome oxide paint. Mechanical agitators in the tank maintain the proper solution. The large unit seen dipping into the tank is known as a Christmas tree, on which very small parts are hung. Much of the sheet stock is cleaned and painted full size, especially those sheets used in forming the skin for fuselage and wings. Again, 2 hot cleansing solutions are used, the first for the actual cleaning, the second as a rinse. These sheets are painted by spraying. The various processes of treating metal all serve the same purposes: to increase the strength of the airplane without weight penalty and to prolong its life through protecting all surfaces. Here in an assembly jig, the formers for the leading edge of the elevator are set up, and the skin is placed over them. Since this skin was shown as an example of forming operations, it will be followed through now as representative of subassembly in general. From the pilot holes in the skin, rivet holes are drilled through the formers, and the pilot holes themselves are reamed out to the exact size of the rivets. Patent fasteners called Cleco sheet holders are inserted to keep the assembly in perfect alignment. The assembled leading edge of the elevator is now ready for riveting. Airplane riveting is a highly specialized operation. Because every part of the structure carries a share of the total load, and all joints are thus subjected to severe strains, every rivet must fit precisely. To ensure alignment, each of the Cleco fasteners is left in place until the final moment. When the leading edge is completed, it is mounted in another jig where the ribs are attached and the full elevator framework is built up. The completed framework is now ready for its fabric cover. Sewn along 3 edges to form a glove-like pocket, the fabric is fitted over the frame and pinned up. It is then fixed in place by means of wires, which fit into grooves in the ribs. When this operation is finished, the open ends are sewed up by nimble seamstresses, as women, too, play important roles in building America's Air Force. And so the elevator is complete and ready for the assembly line. The wing panel, like the elevator, is built up from the leading edge. Here, the bulkheads are set in place along the leading edge spar. Meanwhile, rivet holes in the various skin surfaces are dimpled in order to flush all rivet heads. The leading edge skin is then set in place over the assembled spar and bulkheads. The skin is securely strapped down and fastened with Cleco holders preparatory to riveting. In a special fixture, the remainder of the wing is built up of spars, ribs, and skin. The wing is finally placed in an upright fixture for the attachment of trailing edge, control surfaces, wing tip, fuel tanks, and a lighting gear. A finished wing panel is rolled away to meet its appointment on the assembly line, while others, waiting their turns, undergo final cleanup and inspection. Various other subassemblies, employ the talents of craftsmen of every description. Aircraft welders, here working on a steel engine brace, must pass a rigid government examination. Meticulous care is exercised in the machining and assembly of oleo struts, as precision fitting is essential to the proper functioning of a hydraulic system. Kapok is stuffed into the pilot's headrest to exact specifications for maximum comfort and safety. Shock cord is cut into proper length and used for the springs on the pilot's seat. Again, in this operation, safety and comfort are the governing factors. The safety belt is thoroughly tested for security and the ease with which it may be unhooked in case of emergency. Seamstresses further ply their trade, here sewing zippers onto gun mount boots, a minor operation, but typical of the multitudinous details. And so throughout the vast, sprawling plant, men and women of 300 separate and distinct trades apply their varied experience and skill in the thousands of tasks necessary to feed the production line of a modern military airplane. The fuselage is the foundation for the final assembly of the airplane. The fuselage of the Bell P-39, shown in construction here, is built around two longitudinal beams, which are assembled in a manner similar to the parts previously shown. Upon completion, these are joined to a center section which provides the carry-through for the detachable wing panels. The two beams extend from the nose back under the cabin and to a point behind the engine, the rear portion of the fuselage and tail surfaces being added later. When these basic parts have been bolted together, the unit is lifted out of the fixture and moved to a more flexible one for building up the trailing edge of the center section, the cockpit floor, the engine mount, and an auxiliary transverse beam which further supports the tremendous loads centered here. After final inspection and cleanup, during which the unit is turned over in the fixture for easier access to all parts, the fuselage is rolled away to final assembly. Arriving just as the line has moved far enough to make way for it, the structure is attached to an endless chain conveyor, which will carry it down through the various assembly stations. There are 15 principal stations in the line. Activity is coordinated so that the work assigned to all stations requires the same time to complete. Each station is provided with a stock rack in which are stored all materials for the operations performed there. Attached to each is a material control chart by which production control engineers keep constant check on the condition of the entire line. The first 4 stations of the line complete the assembly of the fuselage and the installation of units within. Here again, the structure is turned over as needed to permit easier access and consequently speedier work. Among the vital parts installed are fuel, oil, and vacuum lines and other members of the airplane's nerve system. In the 5th station, the 37mm cannon is mounted in the nose of the airplane. A distinguishing feature of the Airacobra, its installation is made possible through the location of the engine behind the cockpit. When the cannon has been securely bolted to its mount, the cabin is lowered into place, having come off its own sub-assembly line and undergone close inspection by the inspectors of the manufacturer and of the Army Air Corps. As in all modern pursuit models, this cabin is designed to afford the pilot maximum safety and visibility. It is a sturdy framework covered with plexiglass, a new plastic which cannot shatter or become discolored. Moving down the line, the airplane comes into place for the next major installation, the power plant. Here, an Allison V12 engine is swung into position over the structure. It is lowered onto its mount aft of the cabin and directly over the wing. While other pursuit models mount the engine in the nose, in this model, connection between engine and propeller is made through an extension drive shaft. Many hours of work are necessary to secure the engine in place and make all the necessary connections and adjustments. At Station 9, the main production line meets with the end of another sub-assembly line, that of the aft fuselage, into which have been constructed the tail surfaces. A crane is used to lift this from its dolly and carry it into position for attachment to the end of the main fuselage beams. This unit has been kept off the airplane until now to permit workmen free access to the interior of the fuselage for installing the many parts tightly packed within. In the next few stations, various cowlings are affixed, connections are made, instruments and accessories are added, and many adjustments and inspections are made. The airplane is then complete, except for attachment of propeller and wing panels. The propeller, measuring over 12 feet in diameter, is brought to the line on a special dolly. Again, a crane is used to remove it and position it at the nose of the airplane. This is a special model of the Curtiss electric propeller, with the hub hollowed out to accommodate the nose-firing cannon. Advanced checking assures perfect thread alignment, and a final pull on the hub wrench seats the propeller firmly in place. At this point, the structure is rolled into the spray booth. Here, it is given a protective coating and a final coat in accordance with Air Corps specifications. A miniature waterfall serves to carry off the oppressive fumes. Completed wing panels are moved up to the airplane at the 13th station, where they're fastened to the center section. Here, and in the remaining 2 stations, are also attached the controls for ailerons, flaps, alighting gear, and armament. In the hangar of the factory, the completed airplane undergoes further cleanup operations and inspections before it is sent out for flight test. After the prescribed test, the airplane is returned to the hangar for another complete examination by the inspectors of the manufacturer and of the Army Air Corps. Typical are the tests of the controls, during which one inspector checks the stress on the control columns with a tensiometer, while another tests the action of the stick. The nose wheel well is thoroughly examined for clearance and for the performance of the mechanism. Only when an airplane has satisfactorily passed these and hundreds of other final tests do the inspectors approve it for acceptance by the Air Corps. And so the airplane leaves the factory, a job done and well done. Just as every few hours, airplanes leave from all of the nation's many production lines to join the Army Air Corps. And fighters of every type will continue to join in ever-increasing numbers, because thousands of men, anonymous men, are doing their parts in the factories to keep 'em flying.